This is part one on a series on machine learning operations security, MLOps security. The first one that we're going to talk about here in part one of the series is Databricks AI Security Framework. And to give an overview, the Databricks AI Security Framework offers a comprehensive approach to securing the entire AI ML lifecycle within an organization. It provides the necessary security controls, best practices, and governance to help manage the risk associated with deploying AI ML systems such as model bias, data privacy, and model security. By integrating with existing security tools and frameworks, the framework enables a holistic security posture for AI ML workflows. This helps organizations achieve compliance with industry regulations, maintain visibility and auditability into their process, and ultimately deploy in a secure and scalable manner. Overall, the Databricks AI Security Framework is a valuable asset for organizations looking to operationalize AI ML security at an enterprise level scale. So going into the overview a little bit more, provides that comprehensive approach, focuses on the entire life cycle of AI ML. So looking at like DevSecOps and what's been done for regular deployment models, whether it be on-prem and in the cloud, containerized applications, those secure coding practices are now being applied to the ML lifecycle, and MLOps is really evolving to be MLSecOps. This framework also provides security controls, best practice, and governance for each stage. It breaks it down by stage, teaches you how to threat model and look at your attack surfaces, and then recommends controls to mitigate any vulnerabilities that are exposed there, and harden those systems as well with recommendations for some tooling both from Databricks and some other vendors. It really helps you with your risk management program there. And if you have security programs for secure coding and you have a risk management program and you're not focused on ML, you're really just opening up a huge threat surface, and you're not addressing your practice holistically, and you're setting yourself up for a breach because of this large gap in your security. These practices need to evolve to really handle this, and it is so different than just regular secure coding practices dealing with the types of attack vectors that are present in machine learning models. This framework also integrates with existing security tools and frameworks for a holistic security posture. The integration is important because you have processes in place. You don't want to be disruptive to the business while providing this enabling framework for security here. It enables compliance with new regulations that are popping up, but it also gives you an audit trail of things you've done leading up to some new regulations coming into place, so you're already proactively prepared to not have any delays in the deployment of models or use of models to give yourself a market advantage for your business. Provides visibility and auditability into the processes, so it really shows you everything that's happening at every stage of the life cycle, talking from raw data acquisition to the cleaning of the data to the actual model updating and enhancements through something like a RAG process, where you have a retrieval augmentation process there, so that you have up-to-date online training of the model and it's not stagnant because it was trained at an earlier period of time. So really just supporting the security here and helping organizations operationalize, so it's not like a one-off POC for machine learning anymore. It's really part of your day-to-day operations and should be treated as such. So core foundations of the framework, it's that common set of controls. It's the tech risk that helps you threat model and put those threat models into your repository and your risk register. Correlates the risk to control, so it's very easy to audit and ensure that you're at a maturity level that's sufficient for the models that you have deployed in the frameworks you have out there. And then it also identifies the Databricks products that facilitate secure machine learning ops. So the technical risk and controls, I won't go through all this in its entirety. I just want to show some of the things that are in the framework. And here you have from that raw data prep stage, the data sets and how you secure them, and how you segment access controls to those and do user access reviews, the governance behind the models and how you benchmark and test, the algorithms being used, and once again, the benchmarking and evaluation, how you model management practices. So what are your versioning? How do you look for degradation of performance in there, or possible adversarial attacks, data poisoning attacks, and some other things that we'll get into with prompt injection that changes the way that the model behaves from the time you benchmark to the certain points in time at deployment. And inference responses, so can you extract sensitive data, or is it hardened to that? And really just getting into the overall security here. This is just a little overview. It shows the type of models that this framework is really geared around. And like I said, the retrieval augmented models here with the LLMs is very important, because that augmentation, while it increases the performance of the model significantly, it also gives the opportunity for some adversarial attacks that you got to be very conscious about. 55 different risks, that's a pretty broad threat surface for you to evaluate and risk assess on a regular basis. And then the controls are great because they have overlap between the different risks. You can really proactively handle forthcoming situations, and also make sure that you have defense in depth for your MLOps practice. So the ecosystem tools, that the first one we talk about in there, and I won't go into the product, that's another review for another time, but ML Flow is great because it has separation of duties, so you don't have developers whose credentials could be compromised, and then with those compromised credentials, something can be pushed to production that shouldn't have been. You have a lot of security around those pull requests and push to various staging and production, etc. It checks for secure controlled libraries for developer use, so it goes through your regular vulnerability scanning and everything else, and these are approved libraries rather than developers using something that might have a supply chain attack code injected in there somewhere, backdoors, data exfiltration, things of that nature. Environment provisioning, so that you, once again, you have approved container software. You have a control over whether there's secrets management or secrets being leaked into the environment or the source code. And then model versioning is important, so you could revert back to a prior model if some degradation has occurred. The next tool is the Unity Catalog, and this is really so that you can have centralized access control, auditing, and lineage and data discovery capabilities. So if the data's changed, the target labels have changed, with some poisoning attacks, or even just having that user access control reviews where you have your folder structure out there in these catalogs, and you could segment it by customer, by actual individual users, and make sure that the access is restricted to the pertinent party and doesn't expand to other parties where you could extract data about another company, another user or individual that they shouldn't have access to. And it really segments the data in a way that makes securing it from those cross attacks possible. Next, here is just kind of general overview some of the policies that Databricks has on their system tools, the trust, and they are audited regularly. They use state-of-the-art technology to secure their platform, go through regular tests like SOC 2 Type 2, ISO 27001, and they're fully transparent to that. And what I thought was really cool about this is they also have transparency into the architecture itself, which really lends itself to having a lot of confidence in the platform that you're using there when you understand every single step of the actual platform itself and how it operates and what checks are in place at every stage, just like you would with a DevSecOps secure coding pipeline. So getting into an example of how this framework works, what we're going to look at is a simple but common attack, prompt injection. So there's two types. There's a direct prompt injection when a user injects text that is intended to alter the behavior of the LLM. So, there's system prompts before the prompt that you actually place into the system that gives it a bit of a directive and narrows the scope of what the chatbot should respond with. Well, there are attacks that can change that system prompt if not secured enough, and now you can get it to do behaviors such as expose secrets that might be in directories that shouldn't be accessible, but that's another problem, or to believe something that's true that's not true by changing the context of what it has in its knowledge base, and then other users will be fed that misinformation. And then indirect really gets into the RAG process, that augmented retrieval process, where you train at a certain period of time and the model becomes stagnant as time goes on. Training, retraining is very expensive. So you're able to put real-time documents that the model will look at before it looks into its training data, essentially. So it has the most up-to-date news. And it's very critical that that information is accurate, truthful, and being interpreted by the model correctly. Well, sometimes people, through prompt injection, these adversarial actors, could add different context that changes the facts, and the model believes it to be true. And then you have users receiving information that's inaccurate, not correct, and could be very damaging both to company reputation and the users of that system. So at this time, I'm just going to jump in and show how this would work in a model if we're looking at this threat vector of prompt injection and how the model helps you address it. So right here, we're on there. You would just go to Risk and AI Systems Components. This is the 55 different risks they have. Right here, under the staging, model deployment and serving, this is where you want to check for some of these common vulnerabilities, just like static code analysis. And we have prompt injection as risk 9.1. If we click on that, it'll give you a description of what the risk is, how a adversarial actor would take advantage of it, and then it gives you the AI Security Framework mitigating controls. And you'll see many of these controls are the same you would do in a secure coding practice, SSO with IDP and MFA, different access control groups and list, really segmenting data, encrypting models, just going through, set up inference tables for monitoring, logging, and there's a lot of different things that can be done, including adding some auxiliary cybersecurity architecture techniques like an AI firewall, which really operates like your web application firewall. It looks for different prompt injection rules. You can custom tune it and really stop those before it even hits the model. And there are some other tools out there that do that kind of deep packet inspection as well. But this gives you a really good baseline for some defense in depth on how to control that. And, really that's some of the safeguards you need to take. And as you see, you can get back into some of these risk in AI systems from different stages, and it'll give you all the risk at all the different stages. And you can really use this to threat model your systems, as well as look to see if you have the mitigating controls in place to reduce the likelihood of a incident occurring, and to really safeguard these assets out there. And then, kind of lastly, I just wanted to touch on compliance issues is, with the new Biden executive order for standards of AI safety, you have to report on incidents that occur, and having a framework like this in place where you have proper risk register, where you identify the risks to your AI models, and you have your different decisions on whether you decide to accept, mitigate, transfer, or avoid these risks, really shows due diligence in how you handle these, and your seriousness around mitigating AI threats and having the best and safest models out there. And the same goes for the European Union Artificial Intelligence Act that just came out. And I imagine these are going to start to become criteria in a lot of other compliance frameworks out there and audits that you may want to partake in. So it's worth getting a jump start on it and doing that due diligence now. So thank you. This is part one. Part two, we're going to dive into the NIST 101 Artificial Intelligence Risk Management Framework. And then in part three, we're going to type into the MITRE Atlas framework that works just like the regular MITRE attack, but it's specific for attacks on AI. Thank you.